Hello and welcome to Amateur Radio Topics episode 4. I'm Kevin, VK6 Lima Whiskey, and in this episode we are taking a look at antenna modelling software and also antenna analyzers. Both of these are really useful tools to design, build your own antennas, and also useful for experimenting with different antenna characteristics to suit the type of antenna that you need for your amateur radio activities. So first of all, the antenna modelling software. I use a program called EasyNEC. It's widely available. Also, you can download a trial version, which does have limited segments for each antenna. But actually, if you're just building simple dipoles or verticals, or maybe loops, there's enough segments there for you to be able to assess the antenna, work out what you need to do. If you're building more complex antennas such as wire beams or multi-element antennas, multi-element quads, then you will need the paid for version. But it's not that expensive. I think it's well worth the money. And I've used this program a lot over the last probably 10 years. And it's helped me tremendously to be able to design and build various wire antennas, check out the design, have a look at the radiation pattern, look at the angle of radiation, work out what really will work, and also give some fairly useful information in relation to feed point impedances and matching. So it's quite easy to download the program first of all, and once you have initially downloaded it, you can start to design some antennas. Now the program I think comes preloaded with some basic antennas such as a dipole and vertical, that sort of thing. There's various antennas I think in the library after you download it. So you can use these as a starting point. Essentially you have X, Y and Z coordinates. The Z is the height. And it's fairly easy to work this out. Sometimes when you're starting you just need to sketch it out on a piece of paper in terms of the dimensions. And you can use either feet and inches, or you can use meters. It doesn't really matter. The program will accept either of those units. So if you design a typical antenna, we'll go back to the dipole, which is a fairly simple example, and you can adjust the height of the antenna, you can adjust the length of the legs, you can adjust the position of the feed point, which of course with the dipole is normally in the middle. And you can have a look at the radiation pattern, angle of radiation. You will see that when the antenna gets to a certain height, normally around about half wavelength above the ground, that you're starting to get some nice low angle loads either side of the antenna. A lower angle of radiation, normally either side of the antenna or broadside to the antenna. So you can adjust all these parameters. You can make adjustment for the type of wire and also the wire loss. You can make adjustment for the type of ground that you have. I find it useful to use a real ground type simulation rather than a free space type radiation pattern. This gives you some idea of the effect of the ground. You can add in a load, and obviously you can add in a source. And it gives you various options to enhance obviously the design of the antenna. And this is all really useful because obviously if you build an antenna and you put it up in the air, you don't really know quite how that's perhaps going to work. And I've actually found with this program that if I program in the type of wire, the size of the wire, if I'm using plain enamel copper wire, pretty well what I build and what I model is borne out by the performance of the antenna. It's not a perfect arrangement because you can never take into account every single possible local condition, but it gives you a very good idea of how that antenna will perform. And I've designed and built dipoles, verticals, quads, multi-element beams. And in each case, this is fairly good for sorting out what's really important. And sometimes the results are quite surprising in terms of the design of the antenna, the height above ground, the effect of bending or the elements, or installing an antenna as an inverted V. And also, as you go lower in frequency, you find that when you're designing dipoles or loops, when they're being low to the ground, it's quite hard to get that lower angle of radiation, particularly if the antenna is horizontally polarized. So then sometimes you're looking more at a vertically polarized antenna, such as a vertical or a vertically polarized loop, and these can be really useful antennas. It just depends on what you're trying to do with the antenna. If you only want to make local contacts, a high angle radiator is absolutely fine. That's exactly what you need. If you want to work DX, you do need to try and concentrate on a design which will give you that low angle of radiation in the desired direction. And it's the same if you're designing multi-element wire beams. Even if it's just a 2-element beam, you can get a fairly good idea of the effect of the spacing, the height above ground, the front to back ratio, and the enhancement that having a second element on a beam will give you. And one of the big advantages by having the second element is it lowers the angle of radiation in the desired direction. And then of course you can switch that beam electrically, or you can turn it into a rotatable beam. It gives you lots of options, and certainly the extra gain that even a 2-element beam, the extra gain that gives you is really quite important and will make a difference no matter what mode of operation you're interested in. I guess the thing is that whatever mode of operation you're interested in, it all comes back to the antenna in the end. The antenna is probably the most important part, and so if you can maximize the performance of the antenna, it helps you on transmit, and it helps you enormously on receive as well. So I would recommend downloading one of these types of programs. It doesn't have to be Easy NEC. There's a lot of others available. You can take a look at them. They all work more or less in the same way. You can change all the parameters I've just discussed: wire length, wire height above ground, impedance of the feed line, the type of wire. You can even select wire with insulation. It makes some sort of calculation for the velocity factor that the insulation introduces. So it's a very good way to get yourself familiar with what's really important with the antenna design. And it will also run an SWR plot, which is also important, and it will give you an idea of the feed point impedance, the match, and the SWR plotted against frequency. And if you're trying to design a multiband antenna, for example, it will plot all the way from 1.8 megs all the way up to 30 megs and give you those feed point impedances at various frequencies. So all in all, very useful. Also, it does help if you're placing antennas close together. I have 2 towers here around about 15 meters apart, and if I build something on one tower and I've got an antenna on the other tower, inevitably there's some sort of interaction, particularly if the antennas happen to be pointing towards one another various occasions. So you can plot this as well. It gives a 2D plot which shows the elevation and the azimuth in terms of the radiation pattern, and also it gives a 3-dimensional plot as well, which is really useful, and it shows the currents on the wires associated with these plots. So you can take a look and make sure that you've got the currents balanced in a beam antenna, or in a dipole. You can make sure that the dipole has the high current point at the center, which is normally the top of the dipole anyway, particularly if it's an inverted V. So it helps with working out the current distribution on the antenna itself. And once you've done all that, you can save it and you can refer to it. And I've got many designs that I've formulated over the years where I've had an idea about something. I've designed the antenna using one of these programs. Haven't actually built it yet. Designed it, thought that's pretty useful, save it, come back to it a bit later, maybe modify it a bit. And I'm quite fortunate here. I have some space for antenna experimentation. I'm in about 2.5 acres, so that does help. It's obviously much more difficult if you've got limited space, but if you have limited space, you can only work with what you've got, and I would still recommend using this computer modeling tool to get the best possible result for the space you have. The alternative, of course, is just to build the antenna, build it to formula, put it up in the air, see how it works. That's actually not a bad way to do things either. But I guess there's quite a few things you have to adjust once you've gone through that process, and it's about cut and try, which is the way I guess we always used to do things. This just helps to build something that's going to work and it saves you a lot of time. So normally once I've built something once you've designed the antenna, it's time to build it. And this is reasonably straightforward. The modeling software gives you the length of the wires and indicates obviously where the feed point will be. So it's just a question of choosing the wire you'd like to use. And if you want to keep it inconspicuous, you can use a fairly thin wire. You don't have to use a thick wire. On the HF bands, it's not really going to make much difference with the thickness of the wire. Black wire is actually quite good. Black wire, if you want to keep the wire fairly invisible, black seems to be the best colour. So cut the wires to length. You need to have some sort of a centre insulator. Terminate the coax to the wires at the centre. I find that you need a fairly decent soldering iron. If you're trying to solder and you're not in the shack or the shed, if you're trying to do something more or less in the field, a cordless soldering iron or gas-powered soldering iron is very useful. You don't have to solder those connections. Sometimes for various antennas I've used electrical connectors, heavy-duty electrical connectors with a screw-down clamp, and providing they're well insulated, well taped up at the end, then these work quite well. I've uncovered these after sometimes several years, and if you use self-amalgamating rubberized tape first and then a layer of vinyl tape over the top of that, really not much moisture will get in there and connection stays very good. So you don't have to solder those connections at the center between the coax and the wire, but it is important you try and stop the moisture from getting in there. So there's various ways of doing this, and we'll probably cover some of this in a future episode. At the ends of the wires you need some sort of insulator. These can be the generic insulators that are generic black insulators that work quite well. You can use polycarbonate insulators. They actually work very well. You can buy sheets of polycarbonate. You can cut this up, drill some holes, whether it's clear polycarbonate, white polycarbonate, black, it all works pretty well the same. It's a pretty good insulator at HF frequencies. And then it's a question of getting the antenna up into the air. So you may be supporting it from a tree, a mast, part of the house. The important thing is to keep it in the clear, keep it away from other objects if you can, get it as high as possible. And then once you've done all that, you will want to test it out, obviously. And you might just then connect it to your radio. Most rigs these days have an SWR meter built into them. Check out the SWR. Most radios also have a tuner built into them. And if the SWR is anything under 3 to 1, probably your tuner on the radio will cover that and tune out the discrepancy to give a good match to your transceiver. But it's also very useful before you go through that stage to have a test with an antenna analyzer. So I've had one of these now for probably about 7 or 8 years. It's a really useful tool. So essentially, instead of plugging the coax feed back into your radio initially you put it into the antenna analyzer, and you can control the frequency, and you can control the range of frequencies that it will scan. It performs quite a few other functions. I've got a Rig Expert antenna analyzer which covers the HF bands and also 6 meters, I think. It's an AA54. Quite a solid construction. It's good for field work, and I found it to be very reliable. So this will give you an idea of the SWR for a given frequency, and it's quite useful for fine-tuning the antenna, particularly before you even plug it into the radio. So what normally happens is when you put this antenna up, for various reasons, sometimes due to ground conductivity, proximity of other objects, the type of wire you've used, you might well find the antenna needs to be trimmed. So particularly in the case of PVC or plastic coated wire, this has what is called a velocity factor, and that effectively shortens the electrical length of the wire by a factor. But the factor can vary depending on the type of insulation and the thickness of the insulation on the wire. So quite often, if you were to build this to, say, a bare copper wire or enamelled wire formula, and then you decide to build it with plastic or PVC coated wire, you will probably have to shorten the antenna once you put it into the air. But that's not too bad, because it's much easier to shorten the antenna than it is sometimes to lengthen it. And you can do this in two ways. You can either cut the antenna, or you can fold the ends of the antenna back on itself. Both work fairly well. I tend to fold initially to try and get an idea of where we are in the band and what needs to happen. Obviously, if the antenna is too long, it will resonate at too low a frequency, and if the antenna is too short, it will resonate at too high a frequency. So you soon get the idea of what you need to do in terms of a final adjustment. But you can do all this out in the field with an antenna analyzer, a length of coax connected to the center of the antenna, and it's again a great time saver. And I've found that once I get the result right with this, I plug it into the radio, everything's normally very good. I can't think of a single instance where the antenna analyzer hasn't given me the match that I would like on the radio. Sometimes you can get various lengths of coax that don't necessarily work with certain frequencies, but I would first of all concentrate on trying to get a good match with whatever length you have there. If you find that you're really struggling with this, you can maybe take a look at the length of coax you've got, and you can always increase the length of coax. The increased length can be coiled up either at the shack point, the base of the mast, or the tree, or the tower, and this doesn't do any harm. This will act as a bit of a RF choke type balance situation, so that can help currents from flowing down the outside of the coax, and that may help to get a match. But generally speaking, you can normally work with what you've got, and it's just on the odd occasion you might get a length of coax that just doesn't help you with the match on a certain frequency. So these two tools really will make your life so much easier for designing, building, and experimenting with antennas. And I enjoy experimenting with antennas because I always think I can make something a bit better. There's lots of obviously antenna designs in textbooks and on the internet, and it's also quite useful to sometimes run one of these designs through the antenna modeling program and see how it comes up, see exactly what the characteristics of the antenna will be. The antenna modeling program will give you that. So there's some quite popular antennas out there that have been around over the years that have fairly good pedigree in terms of the claim results, and it's quite fun just to plug the parameters in and have a look and see exactly what this antenna does. Okay, well, this concludes the episode on the antenna modeling tools, and in the next episode I think we're going to have a closer look at the wire beams, quad loops, verticals, some other types of antenna you can build, and again once you get into multi-element antennas, these tools are very useful indeed. I'm currently working on some material which will appear on my website, zigzagwest.com. Just go to Amateur Radio Podcast, take a look at the blog, and there will be some more information on there in relation to this episode and also the previous episodes. So, thanks for tuning in, and 73s for now from Kevin, VK6 Lima Whiskey.